Okay, number one says you launch a ball at 45 degrees on level ground with a muzzle velocity of 100 meters per second. So, level ground, 45 degrees, 100 meters per second. How long is it in the air? How high does it go? How far does it go? So we break it into its vertical and horizontal pieces. Vertically, these are the things that I could know about this problem: initial velocity, final acceleration, time, and distance. Horizontally, it moves at a constant speed: velocity, distance, and time. So the first thing I have to do is find the horizontal component and the vertical component of my velocity. So I use the sine and the cosine. So I take 100 times the sine of 45. And you have to make sure you're in degree mode, and you get 70.7. And because this is a 45, 45, 90 triangle, this is also going to be 70.7. So the initial velocity is 70.7 meters per second. That's in the vertical direction. In the horizontal, it's also 70.7 meters per second. Let's see. I'm going to take part of this special spot right there. The vertical velocity right there is 0. The acceleration is always negative 9.8. So I can find the time, and I can also find the distance. I'll just plug it into either one of my equations here. So I'll go VF equals VI plus AT. So 0 equals 70.7 plus negative 9.8 T. So I take 70.7 and I divide by 9.8, and I get 7.21. So that's how much time, be careful, that's how much time it took to get right there. So how long is it in the air? It's in the air for 14.42. You double that. So that's the answer to part A. How long is it in the air? 14.42 seconds. With significant figures, I should probably go 14.4 seconds. Okay, to figure out how high it went, that's a vertical distance. So I'll solve for D equals VIT plus 1/2 AT squared. The initial velocity is 70.7. The time to right here now, mind you, is 7.21 plus 1/2 negative 9.8, 7.21 squared. So now I just crank that through on my calculator. And I get 255 meters. So how high does it go? 255 meters. And how far does it go? Now that's a horizontal distance. So now that's looking for the horizontal distance. This time and this time are related. The time it takes to go from here to here is the 14.4 seconds. So I use velocity is equal to distance divided by time. The velocity being 70.7 in the horizontal direction. The distance is unknown, and the time is 14.4. So you take 70.7 multiplied by 14.4, and you end up with 1,020, 1020 meters. Now there are other ways to do this problem. Instead of using 0 for the final velocity, I could have used negative 70.7, and then that would have given me the whole time. Instead of having to double it, I could have put a negative 70.7 in for where 0 is, and I would have gotten 14.4 right away. So there's lots of ways you can do these problems. Don't let me buttonhole you.